Record. Oh, perfect. All right, so let us begin. Okay, so unit 1 review guide. All right, so oops, I'm gonna turn this on. So first thing first, you guys already took the quiz, so I'm gonna ignore that. The homework assignment is basically finish your late work assignments and also the study guide that you guys picked up. It's also online, and I'm going to post the answer key as well. And probably today or next class, we will go over together. Okay, just to make sure that you guys are on top of things. And the test is on Friday. Okay. So the following notes we're going to go over is the nuclear decay. I don't know if you guys have finished the gizmos or not, but we're going to go over some notes on that part. The average atomic mass, mole calculation, periodic table, and elements, and some lab safety skills. So before we go on to anything in general, could you guys answer this following question? It should be on your screen. So it says label one on the left. So I would like you guys to kind of label what these numbers represent with your own abilities. So don't look at any notes. Just try your best and answer those questions. Okay. So yeah. All right, so whenever you guys are ready, we will go over the notes or go over what's next. Okay. So if you guys focus today, you guys are good to go for the tests. Okay. So let's check on what you guys think about the parts. So first thing first, we have atomic number. Very interesting. Atomic number on the top left. Is that correct? Is 35 an atomic number? Okay. Top left, remember guys, look at the periodic table first of all, and tell me what is the atomic number for Cl? Okay. Let's see. 17, perfect. Then that means the bottom left is actually the atomic number. Okay. So this is the atomic number, but what's 35 then? It's a mass number, not atomic mass, because remember, atomic mass is when it's in decimal form. A mass number, on the other hand, is a whole number. Okay. So remember that when you guys are working on this. Whoa. Okay. So we said mass number on the top, atomic N on the bottom left. Perfect. Okay. 35 is the mass number, which is also proton plus neutron. 17 is the atomic number, which represents the proton. Perfect. Okay. Yep. So instead of atomic mass, it should be mass number. Let's see. On my previous classes, I had some interesting pictures, but I guess this time it's not. So Okay, maybe I'll take this one. This has no description. Oh, it has descriptions. Perfect. Perfect. Okay, perfect. Perfect. I love it. Do you guys know what 35 is here? What do you guys think? Someone new. What? I mean, you're right. It's actually the mass number. Yeah. So 35 represents the mass number. So sometimes we can set it up as the top left, or we can set it up as the bottom left, just like that, depending on the question. Okay, love the smiley face. Thank you. And that's it. So that should be good to go. All right, so I'm going to move on to the next part. So here's some information you guys need to know. If you guys don't know this, then we're back to day one. So 35 is the mass number, and 17 is the atomic number. So if you guys remember from your gizmos, if you guys have done it, do you guys remember what the alpha particle is by any chance? What was it? You were saying?
I don't know. I feel like well, that's actually what came out.
Okay. Yes, go ahead. He, which is?
Helium.
Yes, helium. Perfect. So alpha particle is helium. And what is beta particle then? Does anyone know?
An electron, basically.
Electron. Perfect. There's your picture. So you guys probably have seen this in the Gizmos website itself. We have the helium as alpha particle, which has 4 mass number, following with 2 atomic number. And we have the electron, which has 0 mass with -1 as its charge. Yes. Yes. Alpha particle is always helium. Beta particle is always electron. That's always how it is. Okay. Now, here's the most important thing that we need to know for the test. So if you guys pay attention, it would be best. All right, not a problem. So for this question, let's start out with an alpha particle here. Can someone tell me what is the missing top left corner for this calculation? So how do we get from 238 and split to 4 and something? What is that something? Can someone tell me? Perfect. Yep. So the top left is going to be 234. How do we figure that out? 238 minus 4, so the 4 came from the helium to get the mass. Now, if this does not make sense, another way you can do it is 4 plus 234 to get 238. So that's another way if you guys are kind of confused about subtracting and more comfortable with addition. So you can use this method or the method that I just told you just now by adding the 2 masses together. So, following with the atomic numbers, the same thing. 92 minus 2, 2 from the helium, to get 90, or 2 plus 90 gets you to 92. Now, always when they provide you an atomic number, you have to figure out what the element is, which becomes TH from the periodic table. Does that make sense for everyone? Just want to make sure. Yeah, go ahead. That's okay. So what I can say is 238, which is from the given answer. You can subtract 4 to get 234, or you can do 4 plus 238. Oh, no, not 238. 234 to get to 238. That's fine. So either way is fine. They both basically gave you the same answer, only it's flip-flopped. Same goes with the atomic number. You can do 92 minus 2 to get 90, or 2 plus 90 to get 92. So that's how it is. TH is the element from the 90. So if you check on the periodic table for atomic number 90, that should give you TH on there. Yeah. So this was also in the gizmos if you guys have not recognized it yet. So that should be the first answer on your gizmos. Okay. Now let's try with the electrons or beta particles. So let's see. Gabe, could you tell me how to do this? You can take a guess. Oh, wait. Did I say it right? It's Gabe, right? Yeah. Do you know how to solve this question? No? Okay. So let's see. Okay, perfect. So the answer for this one is 238, because if you subtract by 0 from the 0 mass, it will get you to the same number. When you have a -1, okay, when you're subtracting 92 with -1, negative times a negative becomes positive. So at the end, instead of having 91, you're going to have 93 as an answer. Okay, so perfect. Thank you. And then you get NP, which is from the periodic table with the atomic number of 93. Does this make sense to you guys? Because I do need to make sure, because this is definitely on the test, especially like how to find the missing elements. Okay, so if you guys want to practice more on that, please do so. It's also on the gizmo, so feel free to do that. Now let's review some of the average atomic mass. Average atomic mass is mass number times the abundance plus mass number times the abundance. Can someone tell me what is abundance? It doesn't have to be technical definition, just something. Yeah. Close. Something else. Something else. What is the symbol that you see in the problem for abundance in a problem? Was it? No, I mean, there is a unit for that number specifically.
Oh, is it the A and B?
Not that one. Not that one. What's in a pie chart? What's the unit that we use? What was it? Percentages. So if you guys remember, abundance is when we change the percent into a decimal. Okay. So if I say like 70%, what is that in decimal form? Anyone? 0.7. Thank you. Appreciate it. So that's how it's done for average atomic mass. So what I would like you guys to do is try this question out. Okay. It should pop up on your screen. So please try to solve that question. I'll give you guys some time to do it. So the question says, what is the average atomic mass if there are 70% of nitrogen 15 and 30% of nitrogen 14? So try to solve this out. I'll come by and see if you guys are on top of things or not. I just changed the numbers. Okay, so basically we'll just have to use this equation. And always remember if it's right next to each other, then they're always going to be right next to that. Okay, so if it's 0.7. Also, guys, just a heads up, if you guys are taking the test, you should show your work later on. So I'll come back. Oh, no. So remember we have to mass number. Oh, really? Plus 0.3.
So basically, you just turn the something. What is that? Okay, so that was 0.7 and then 0.3, right? Then what do you do with that? You would add it. You just add it. The formula is right here. So it'd be 0.10.
I'll be right there.
Like,
Okay, so that's the first one.
and then you add those two.
Yeah, 13.
Okay, but you just have to multiply, make the percentages into decimal and multiply like the first number into this one and the second one. 14 and then. Oh, so you take it to decimal percentage.
So, yeah, mass number, someone figured it out. Mass number, first mass number. 15.
Go over them. So you. So you look at 70 times 30, and then whatever you get, you multiply both the numbers. No, you multiply 7 times 15. You multiply 7. Add 0.2. I think I got it, guys. Is it so we 14.7?
Yeah, facts. I got that shit before. No, I did not. I have a 6.9 GPA. I think it goes faster.
Get what you're supposed to do?
Yeah.
Sure.
Yeah, see, I'm allowed when I get the answer right. Yeah.
Have the same answer. I think I have a problem right now. Do you not have that much? Damn. Like, this is my personal bubble house. Ooh.
You're right.
Oh, yeah, fruits.
What is it?
Dos tortillas, por favor. 2 tortillas, please.
You didn't have to translate. Wait, you guys get it? What did you get?
Stop cheating.
14.7? Oh, close.
So.
Wait.
So. You probably have don't. So whenever we're talking this.
All I hear is bullshit.
So.
Why do you feel like that?
What's wrong with that?
What? Those are the Catholic schools. And what about?
What's up?
No way.
No way. And then I'm almost done with my poster. That's good. Take it off.
Yeah.
I will give it a try.
All right, guys, so let's double check on what you guys have, because I don't want to make the recordings too long. So let's see, we have 14.7, we have this question mark. I don't know where this 15% came from. Whoever did this. It should be 0.3 instead of 0.15. So not sure how that happened. Yo, what's up? Uh-huh. Well, I mean, the percent is going to be given to you, unless you have to figure it out. Yeah. So you're only moving the decimal to the left 2 times from the percent. That's all. Yeah. It's all right. So technically, how you're supposed to get is this. 15 is the mass here, times 0.7, because 70% is right next to it, plus 14 times 0.3 to get 14.7, which majority of you guys got the answer. Atomic mass units, but that is going to be your unit for average atomic mass. Okay. So whenever you guys are answering this kind of questions, remember to put AMU. That is your unit for average atomic mass. Okay. AMU. Yeah. Now, going on to moles. The only moles that you guys have to know for now is the molar mass, which you can find from the periodic table. Now, you guys probably have seen this equation before again. The given number, which is the number that you see from the problem itself, times the unit wanted, what you're trying to figure out. So if the question says, what is the mole? You're figuring out the mole. What is the mass? You're figuring out the mass. The unit given, on the other hand, is the unit you want to get rid of. So if the question says, change from grams to mole, then what you're going to have is grams over here. The unit you want, mole, is going to be on the top, just like that. But the unit on the bottom as a denominator should be in grams, because you want to get rid of them when you divide it. Does that make sense? Okay, it might be confusing, but we do need to make sure, because in unit 2, there is going to be a continuation of this. So I do want to make sure that everyone gets this, not just for this test, but also for the next unit. Okay, if it's still confusing, I'm staying after school on Wednesdays, or you guys can ask me for a Zoom meeting, and I can do that when you guys are at home. Okay, that's fine too. So just email me and I'll work something out. Okay. All right. So without further ado, if my screen's popping up, oops. I would like you guys to try to solve this problem. Okay. Feel free to use whatever method you want. Try to solve this. And if you guys have any questions, just raise your hand and I'll come by. Okay.
Yo, nigga. Oh, no. Where's the key?
Yeah, but once I have to get this one. Figure it out, bro. Figure it out. You don't mind that. But you're making me break up like when you
Yo, what's up?
No habla inglés.
So,
And they're round up.
No habla inglés.
round to the two.
No habla inglés. I speak Spanish.
That's I'll go too long. So the first thing you have to write down is 2.65. Oh, yeah. Type it off.
Yeah, at least
It's empty.
Yes, queen.
It says, what is
sorry.
So the unit
Maybe
number.
it's fine for all. And you cover up the
So
whole
that
page.
is when you write down the words.
It's like you don't know. It's cancer. That is. You said that was for the unit given, there's one more, right? Ooh, found it. Why is it?
Right there. Then, so that's what
Meow.
No.
What could possibly
The
go
one
wrong?
up here, that's gonna be on the farther. I just find so what number is that? So. Yes, profit. Can I help?
So first thing first, why don't you draw a chart?
Silence. All right, so let's go over the answer for this one. Okay. So this is what you guys should have gotten. Okay. If it's close enough to this answer, perfect. So the first step, what you guys have to do is make sure that you guys write the problem first. Okay, I've seen a couple of you guys write this mass in the front. Please don't do that because that will confuse you what you started out with. Yes, Brian.
I got 0.96.
0.96.
Like 521.92.
Not sure.
Does that really matter?
It really doesn't matter. If it's close enough, then it's fine. Yeah, so, I mean, this is gonna be in paper, so I'll probably have to manually grade it. So it's not a problem, okay? So always make sure the unit you want to figure out the gram on the top right corner, and you want to get rid of the mole. So make sure to set it up in this format. If you guys have any questions, always come by and I'll help you guys out. So before we move on, what is an isotope? Can someone tell me? Let's see. Gabby, tell me what an isotope is. What's that? Okay, so if I say different number of what? You got three choices: protons, neutrons, electrons. Which one? Nope. Okay, so it's equal number of protons. Perfect. So it is an equal number of protons, but different number of neutrons and masses as well. Okay, so that's good. Just remember that I'm not going to ask a question that says, what is isotope? And I'm not going to ask you for a definition. Okay, it's always going to be about calculation. So don't worry about definitions. But if I give you an example, oh, never mind. So always remember that the question that I will ask in this question would be, if I have iron 55, how many neutrons does that have? And feel free to use the periodic table to solve this question. So we have iron 55. Remember, 55 is the mass number. So what would be our number of neutrons here? How do we figure that out? Do you guys know? Nope, you wouldn't divide. Use,
Subtract the number of protons from the mass number.
Beautiful. Yes. So 55 minus the number of protons of iron, which I believe is 26.
Yeah.
Perfect. So the answer should have gotten you like 29 as your answer. for iron 56. Okay, so always remember, mass number is proton plus neutron, and I'm going to mention that in the next slides as well. Okay. So before we move on, can you guys label this and kind of show me what these represent? Just label these, like label what does 79 mean, or what does 196.97 mean? That's what I would like you guys to do. Try your best. So even though it's placed in a different location compared to the periodic tables you guys have, that does not mean the information would be different. So always remember what these represent. That's very important. Okay. So you guys will be able to draw, type, whatever you guys want in this section. I can't really recommend it. Where it's placed. Okay. All right, so let's go over this. Okay, so on your screen, you'll be able to see the answer. The gold is the name. The atomic number in this case is 79. So always remember, in a periodic table, if the number is in whole number, it's always going to be the atomic number. AU is the symbol, and 196.97 is the atomic mass. Why? It's in decimal form. That's why. And then one last thing I put on the bottom, I said mass number equals proton plus neutron. So always remember that as well. Okay. And one last thing for the atomic number, the proton is equal to the number of electrons. That will probably help you guys out to remember for the test as well. It should be on the study guide as well. So that should work out. Are there any questions so far? We only have a couple more slides left after this. No? Okay. All right, so one last thing. Can you guys tell me, or second to last thing, tell me what's in this atom. Tell me what's in it. Okay, actually, you know what? Just shout out the name. Shout out the answers. Okay, we have proton. What else? Neutrons, electrons. Where are the neutrons and protons located? Where? The nucleus. Perfect. How about the electron? Where is that located? Around the nucleus, outside of the nucleus, that's fine. So here's the following answer. Nucleus has protons and neutrons. They both have positive and no charge. Electrons have a negative charge, which is located in the electron cloud, which we haven't actually gone over yet, but just remember that, that's all. So for this question, can you guys tell me what are rows in the periodic table? What's the name of it?
It's like groups.
Periods, thank you. All right, rows are periods. How about columns? What are they? Groups, perfect. So here's the following. Periods are rows. Columns can be groups or family, but I go by groups, so either ones would be totally fine. Yeah. Technically not, but I'll think about it. I'll think about it. Okay. All right. This is something you guys need to know. Locate where the metals are, the metalloid, and the non-metal. So I'm not gonna explain this, but you guys already know what this is, so there you go. That's all. Okay. This PowerPoint is gonna be in Schoology as well, so you guys can review it. Yes. Question. Hydrogen is non-metal. Yes. So I believe, oh, I already showed you the answer. So alkali metal, where is alkali metal located? Where is that? First row or first column, yes. Alkali metal is in the first column. How about alkali earth metal? Second column, how about the transition metal? Okay, 3 to 12 or this box shape, technically. So perfect. The bottom one actually is these two, but we're not gonna go over it. So no worries. How about halogen groups? Okay, group 17, perfect. And then last one, noble gas, 18. So there you go. That is your answer. Now, actinide and lanthanide, you guys don't have to know that. It's just an extra stuff. It's not that important. So just remember those 5 things on the top, first 5 things. Yes. Oh, go ahead.
Okay, thank you. Oh, so does it matter if we label hydrogen, like, should we label it as an alkali metal or should we like?
So hydrogen is actually contained in alkali metal, even though it's not metal. It's just because of the properties are pretty much similar.
Oh, okay.
That's why. Yeah. Mhm. Perfect. You had a question, Brian?
Oh, no, I was just telling you that he.
Okay, gotcha. All right, last question of the day. How do we read the graduate cylinder?
What?
How do we graduate? The meniscus, perfect. All right, so if you guys don't remember where the meniscus is, it's right below the oval shape. So I'll put the mouse a little bit down. That's where the meniscus is. So always remember that. If you guys don't remember it, good luck. That's all I'm gonna say.
But like, it's not the very top.
It's not the very top. No. It's gonna be slightly downward because the thing is, if we look at this microscopically, there is literally a swoop. There's no water in the middle. So that's why the meniscus is placed in the bottom of that area. But yes. Okay. That's basically it for the presentation part. So if you guys have any questions, feel free to ask. Like I said, you can have a Zoom meeting with me if you guys want to. Okay. Yes. All right. So I'm going to stop recording.